Alright, we're going to start part 2 here. I was having some internet connection issues, so hopefully I've resolved those. Okay, same graph that we were looking at before, but now we want to know through what x values does the function change signs. So if we think about the previous slide, we said from negative infinity to negative 3 that it was negative, it was below that x-axis. But then from negative 3 to positive 3, it was positive. So therefore, its first sign change happens at negative 3. It changed from negative to positive. Okay. Then from negative 3 to 4, it went back to negative. So my next sign change happened at 3 when it went from positive back down to negative. Okay. And then my last sign change happened at 4 because it jumped from negative back to positive. Okay? So I have x values of negative 3, 3, and 4 where those signs changed value. Now take note that at negative 3 and at 4, my graph did not exist. At positive 3, my graph was 0. Okay? We need to be looking for both zeros and for when the graph does not exist for sign changes. Now, there's a little bit of a typo in this slide. It shouldn't say a polynomial function, it should say a rational function. Remember, this section is all about rational functions. Okay. A rational function will only change values through x values that are zeros or through x values where the function is undefined. Okay? Now, this is really just formalizing what we talked about on the previous slide where we said that it changed signs at negative 3, 3, and 4. This is a little bit of a difference from what we looked at in class on Tuesday, though, because on Tuesday when we talked about polynomial functions, we really only had to worry about zeros. Now we have to worry about zeros, and we have to think about where that function is undefined or where it doesn't exist. Okay? Now, just to let you know, zeros and where the function does not exist are often referred to as critical values. So when you hear that phrase critical values, we're talking about where that rational function is 0 and where it does not exist. So let's talk about the process for solving rational inequalities now. This process is pretty much identical to the same process we looked at on Tuesday for solving polynomial inequalities. But like I just mentioned, the big difference is now we're not just looking for zeros on our number line, we're also looking for where that function is undefined or does not exist. Okay? So step 1, still the same it was on Tuesday. We've got to make sure that that right-hand side is 0. Step 2, we need to find the values of x that are zeros, and we need to find the values of x where the function is undefined. We've got to make sure that we're looking for both of those. So we're going to look for where it's zeros and for where it's undefined. Okay? Now, just to simplify things a little bit, zeros come from values that make your numerator 0. So zeros come from values that make numerator 0. Okay. Your undefined values are going to come from values that make your denominator equal to 0. We then need to put all of those numbers, zeros and undefined values, on the number line, that x-axis number line, and we need to use a sign chart to determine when it's positive and when it's negative. Now, you can either plug in values to figure out when it's positive or negative, or you can use the graph. Okay? The graphs of rational inequalities probably are not going to come as quickly to you as they did polynomials, because we pretty much know those general shapes of our polynomials now. So it might be helpful to use your graphing calculator to find the graph on these two. Okay? And then the last step is that we need to give our solution an interval form. Now remember that when we're asked if our rational function is less than or equal to 0, the solution intervals that we're looking for are where it is negative. Okay. If we're asked for the rational function to be greater than or equal to 0, we're looking for those solution intervals where the function is positive. Okay. Now remember that the difference in less than or greater than, or less than or equal to, you can't have less than and greater than, greater than or equal to is going to come down to whether you're using parentheses or whether you're using brackets. Note that when you have a critical value that is undefined or does not exist, you can never include that number in your solution. So what that means is that we always have to use parentheses whenever we have an undefined critical value. Okay, so use parentheses. Alright, so let's actually try some of these now. Alright, here's my first example. I've got the quantity x minus 2 over the quantity x squared minus 9 is greater than 0. So remember, step 1, we're looking to see if we've got 0 on that right-hand side, and we do. Voila, we're good to go there. Step 2, we need to find our zeros, and we need to figure out where it's undefined. Now remember, the zeros come from that numerator equaling 0, and your undefined values come from the denominator equaling 0. Okay? So if we solve the numerator equal to 0, x minus 2 equals 0, we're going to get a 0 of 2. If we solve our denominator equal to 0, we can use the square root property here. So if we add 9 to both sides, we're going to get x squared equals 9. Now remember, if we take the square root of both sides, we've got to remember that this is plus or minus the square root of 9. But the square root of 9 is just 3, so we get x equals plus or minus 3. So we've got 3 different numbers at this point that we're going to put on our number line. We've got 2, positive 3, and we have negative 3. Okay. So we have negative 3, we have 2, and we have positive 3. Now what I like to do is I like to go ahead and label underneath these numbers why it made it to the number line. Okay, so my negative 3 made it because it didn't exist. It was undefined. My 2 made it because it was a 0. I'm going to put a Z for 0. And my 3 made it because it didn't exist. It was undefined. Okay, making that little note for yourself will just help you in writing your final answer in regards to whether or not you need to use parentheses or brackets. Remember, anytime we have a value that does not exist, a value that's undefined, we will always, always, always use parentheses. Okay? If it's a 0, then we've got to make the decision about whether we use a parenthesis or whether we use a bracket based on our original equation. Alright, so step 4 tells me that I need to go and find whether or not it's positive or negative in each region. Okay? Now, this is where you can either plug in values or you can go refer to what the graph looks like. Alright, I don't have my fancy calculator app on my computer at home, so I use an online graphing calculator just to give you an idea of what the graph of x minus 2 over x squared minus 9 looks like. I would encourage you to also put this into your own graphing calculator to see what it looks like on your TI calculator. Okay. Notice over here that when I did enter it into my calculator, I made sure that I put parentheses around the numerator, and then I also put parentheses around the denominator. Okay. If you don't put those parentheses there, you're going to get a very, very different graph. Okay. Now notice here that from negative infinity to negative 3, my function is below my x-axis, so it's negative. Okay? Now, this graph doesn't show it, but I've got a vertical asymptote at negative 3. Okay? You got to use your brain there a little bit. You knew from the algebra part that it was undefined at negative 3. So because it's undefined, there's that vertical asymptote there. Okay? The denominator was equal to 0 there. Then after that asymptote, my function goes positive up until that x value of 2. Then it changes back down to negative. I have another vertical asymptote right there at x equals 3. And then my function goes back to positive. Okay. So that being said, let's go fill in that number line now in our notes. Okay, so from negative infinity to negative 3, based on that graph I just saw, I have a negative in that range. From negative 3 to 2, it was positive. From 2 to 3, it was negative. And from 3 to infinity, it went back to positive. Okay. Now, if you so please, you can always sketch in a little graph for yourself so you've got an idea of what this looks like. So if I wanted to sketch this in, it would look something like this. Okay. Again, it's just going to be rough. Okay. You can choose to sketch that in or not. That's up to you. Okay. So that completes step 4. Now my very last step is to just write my interval. Now realize that in my original question, it wants when it's greater than 0. So I'm looking for where it's positive. So this is positive from negative 3 to 2. My 2 gets a parenthesis because it was greater than. It doesn't have an equal to, so it doesn't get that bracket. And then union 3 to infinity. Now my 3 gets a parenthesis here because remember, anytime it does not exist or where it's undefined, it will always, always, always get that parenthesis. So that's my final answer there. Let's try another one. Alright, this time we are solving the rational inequality x squared minus 6x plus 8 over x squared plus 16x plus 64 is greater than or equal to 0. Alright. First thing that jumps out to me is that I'm going to want to factor this to make it a little bit easier for me to solve my numerator equal to 0 and my denominator equal to 0. So let's go ahead and just factor that real quick. So x squared minus 6x plus 8 is going to factor into x minus 4 times the quantity x minus 2. And my denominator is going to factor into the quantities x plus 8 and x plus 8. Okay. And remember, this is greater than or equal to 0. Alright, step 1, make sure it is greater than or equal to 0. We're good there. It's got that 0 I need. Okay, step 2, I need to find my critical values. I need to find out when it's equal to 0. And remember, that's going to happen when my numerator equals 0. And I need to figure out where it's undefined. And remember, that's going to happen where my denominator equals 0. Alright, so for my zeros, I need to solve x minus 4 times x minus 2 equal to 0. And that's going to give me 2 zeros of x equals 4 and x equals 2. For my undefined portion, I need to solve the quantity x plus 8 times the quantity x plus 8 equals 0. And that's just going to give me one critical value of x equals negative 8. Alright, I get to put all 3 of those values on my number line. I've got negative 8, 2, and 4. Okay. Now remember that negative 8 is on there because it does not exist or it's undefined. 2 is on there because it's a 0, and 4 is on there because it's a 0. So, what we've got to do at this point is we either need to check out what the graph looks like, or we need to go ahead and plug in values in our number line. Okay? Since I graphed the last one, let me go ahead and show you plugging in values on this one. Okay, so if I look in my first region on the left of the number line, I'm talking about that region from negative infinity to negative 8. Okay? I need to plug in a number. I don't know, let's pick -9. Okay, -9 is in that region. The number I get out when I plug this -9 in isn't really important. What's important is whether it's positive or negative. Okay, so if I plug in -9, I'm going to have -9 minus 4 times -9 minus 2 over -9 plus 8 times -9 plus 8. Now, when I do that, I get a positive 143. Again, it really doesn't matter that it's 143. What matters to me is that it's positive. Okay. Now, let's plug in a value in the next interval. So now I'm looking in the interval from -8 to 2. Okay. Anytime I can plug in 0 makes my life really easy. Okay. So let's plug in 0 this time. So I would have 0 minus 4 times 0 minus 2 over 0 plus 8 times 0 plus 8. Now, when I do that, I get either a decimal of 0.125, 125 thousandths, or a reduced fraction of 1/8. But again, the value doesn't matter. What's important to me is that it's positive. Okay. Let's check out our next interval. Now we're going to look between 2 and 4. So in order to avoid fractions or decimals, let's go ahead and pick that number 3. So now I'm looking at 3 minus 4 times 3 minus 2 over 3 plus 8 times 3 plus 8. That gives me a -1, but again, really all I care about is the fact that it's negative. Okay. Now the last interval I need to look at is from 4 to infinity, so let's plug in 5. We'll have 5 minus 4 times 5 minus 2 over 5 plus 8 times 5 plus 8. Okay. And you're going to find out that this gets you back to a positive number. Okay. Now, we're done with step 4 because we put in those signs, positives and negatives for each region. Okay. Now in our final step, we need to write out our interval. Now remember, this time I'm looking at an interval where it's greater than or equal to 0. So that means if I have a 0, I need to use a bracket now. Remember that undefineds or do not exists never get brackets. They will always get parentheses. So we got to be careful about this one. Okay, I'm looking for where it's greater than or equal to 0. So it starts at -infinity. It stays positive until -8 where it goes undefined. Since it's undefined, I've got to use a parenthesis. Union picks up on the other side of that -8, and it goes up until that value of 2. At 2, it is equal to 0, so I can use a bracket. Then I pick up at 4. 4 also gets a bracket because it's a 0, and then I'm going to go all the way to infinity. And infinity always gets a parenthesis. So that's our interval, -8, or -infinity, -8, union -infinity to 2, union 4 to infinity, where 2 and 4 get brackets. Alright, last example here. We've got x plus 8 over x plus 7 is less than -3. Okay. Now, hopefully, some of you right off the bat said, wait a minute, that -3 is not 0. So the very first thing we need to do is we need to rearrange this so that we have a 0 on the right-hand side of the equation. Okay, so we're going to do a little extra work in step 1 this time. So this is going to become x plus 8 over x plus 7. Then plus 3 is less than 0. Okay, so at least it's now got a 0 on the right hand side, but we actually need to go a little bit further in knowing that on the next step we need to set the numerator equal to 0 and the denominator equal to 0. We need to have just one numerator and just one denominator. Okay, so what we need to do is we need to turn this 3 into a fraction. I would like that fraction to have a common denominator with the fraction I already have. So I want that denominator to also be x plus 7. when I do this, what's going to happen is I have to multiply 3 by x plus 7 over x plus 7. Okay? That's a legal move. What I did to the bottom was the same thing as what I did to the top. X plus 7 over x plus 7 is really just like 1. So that's why I can get away with it. Okay? Now, in doing that, I end up with a single fraction of x plus 8 plus 3x plus 21 over x plus 7. Let's clean up that numerator. X plus 3x is going to give me 4x. 8 plus 21 is going to give me 29. And it'll be over that single denominator of x plus 7. Alright, and we are looking for where this is less than 0. Alright, so done with step 1. Now we need to look at step 2. Remember, step 2 is where I'm looking for my zeros and where I'm looking for where it's undefined. So I've got to set my numerator equal to 0, and I have to set my denominator equal to 0. Alright, so for my zeros, I'm setting 4x plus 29 equal to 0, and where it's undefined, or does not exist, I'm setting x plus 7 equal to 0. 4x plus 29 equals 0 is going to give me a 0 of x equals negative 29 over 4. And x plus 7 equals 0 is going to give me an undefined value of negative 7. So this time when I go to make my number line, I've only got 2 numbers on here. I have negative 29 fourths and negative 7. Okay. Negative 29 fourths is less than negative 7, so that's why it's to the left. Okay. Now remember that my negative 29 fourths is on there because it's a 0. My negative 7 is on there because it does not exist. Okay. Let's go ahead and graph this one again. Alright, so here's what your graph looks like, and this window certainly is not the best window, so I would encourage you to also look at your own graphing calculator, and you're going to see the same shape, but it's going to be in a better window for you if you leave it in a standard window. Notice that when I entered this again, I made sure that I put my numerator in parentheses and I put my denominator in parentheses. Okay. Now, also keep in mind that based on the values we found, there was an undefined value at negative 7. So here's my vertical asymptote. And there was a 0 right here at negative 29 fourths. Okay. So, up until that negative 29 fourths, my graph is positive. Then right at that negative 29 fourths, it sneaks just below my x-axis leading up to the vertical asymptote. After that vertical asymptote, my graph goes back up to positive. Okay. So let's go back to our notes now and fill in that number line. Alright, so from negative infinity to negative 29 fourths, we found that that graph was positive. Then in between negative 29 fourths and negative 7, we found that it was negative. And then after that vertical asymptote at negative 7, we found that the graph was again positive. Okay. Now remember, we're looking for where 4x plus 29 over x plus 7 is less than 0. So that key being that we're looking for where it's less than. Okay. So we're looking for where it's negative. In this case, step 5, our final answer, is going to give us an answer of negative 29 fourths to negative 7. Now note that both of these get parentheses. Both of these get parentheses because we're talking about less than 0. So it's not included, so we use those parentheses. Okay. Alright, that's it. That's the very end of our notes for this year. Congratulations, you finished. Okay. Now remember that on Tuesday we're going to start reviewing for our final exam. Okay? If you do have questions about this section, I'm glad to answer them. But I also want to make sure that we have time to get started on that final exam review. So if you have questions, feel free to also send them to me via email, come visit my office. I just want to make sure our time is as productive as possible. Remember that on Tuesday, when we go over that final exam review, you need to come prepared with that departmental final exam review printed already. Remember, it can be found at the bottom of your modules in Canvas. Okay? Have a great weekend, and I'll see you guys on Tuesday.